All right, we're on to, I believe, lesson 4-05, okay, which is going to be um, planes and faces. So we're going to create a reference plane, which is interesting. So reference planes are, um, well, you can create a plane in any space, uh, orientation, angle, and create sketches off of that plane. And so far, all we've used is our origin planes, which is either our XZ, our XY, or our XY. Did I say XY? YZ. Uh, so we've used one of those three origin planes to create sketches. Now we're going to create a new one and we're going to define it ourselves and make sketches within that. All right, and we're going to create a sketch on it, obviously. So upload and open the supplied construction planes fusion file or .f3d file. So we get some practice here. We haven't done this in a while. We're going to open. Nope, not open. Upload. Select files from downloads. This is lesson 4, fusion files, and it was, I think it was construction planes. All right, there we are. Upload. Go ahead and close that. Oh, now we can try and open it. Except it's in here. Okay. Here we are. Let's go like this. Okay. New sketches can be created on custom planes. We kind of already went through this at the beginning. And to do that, we have to create that plane, and we can do that in a number of ways. Here, they're going to have us be using an offset plane. So let's get that highlighted. See, number of ways. You can create planes and axes and points in a wide variety of ways. It's super useful. The offset plane is something that I use most often. And it's also one of the most straightforward. So that's what we're going to start with. Hey. All right. So for the offset plane, control panels, let's see. Choose one of the cube's faces. Use the on-screen manipulator to drag the offset plane 55 millimeters away from the cube's selected face. Click the control panel's OK button. All right, simple enough. Let's click the same face and let's go back 50 minus 55. Okay, did that. Okay, the new plane is now added to the browser inside the construction folder. So here we are. Here's the plane. You can see that it highlights when I toggle over it, and they're asking us to make it invisible. All right. Click construct plane at angle for the control panel's line selection. Choose one of the cube edges. Use the on-screen manipulator to angle the new plane at 45 degrees. So yet again, they're just taking us through a few different ways to make planes. That's 0 degrees, meaning it's flat on the top. If we made it 90 degrees, it would be completely vertical. And they're saying make it 45 with respect to that edge. So yet another way to just create a plane off of an edge. And I'm guessing they want us to turn off the visibility. That's what we just did. Okay, click construct tangent plane for the control plane's face selection. Choose the cylinder's perimeter face. The on-screen manipulator can be used to define the new angle, the new plane's angle. All right. So here we go, tangent plane, cylinder. Okay, let's take a look. What does it mean by angle? 90 degrees. Okay, so it's with respect to kind of like a radial angle from the top face of that cylinder. So if I went 180, it would rotate another 90 degrees looks like counterclockwise around that cylinder. 270. Okay. And we'll leave it at 270. Turn off the visibility. So they're just taking us through all the different ways. Mid-plane. Mid-plane is something that I use quite often as well. I don't use tangent or plane at an angle very often, but midpoint plane, occasionally plane through 3 points, and offset plane. Those are the ones that I use, I would say, most often. But midpoint plane, we'll click the top surface of the cylinder and the bottom surface, and it'll automatically find the middle of that, those two faces, and create a plane there. Super useful. Click OK. Visibility. All right, plane through 2 edges. Simple enough. Okay, you're going to select an edge on the cube and another edge. Ooh. And it'll automatically create a plane that goes through those 2 lines. And the reason we're going through all of these is there's a wide variety to get a plane that you say you want to create a sketch on. But some are better or easier or more straightforward than others, depending on where you want the plane in space and at what angle. And so by knowing all the different ways to create that plane, you can choose maybe the best one or a better one over another. 3-point plane. So instead of using, you need 3 points to create a plane. 2 would just give you a line, okay? And then there's like virtually any number of planes within those 2 points. So you need a 3rd point to create an actual, a fully defined plane. 2 edges does that because 2 edges is virtually unlimited points. But if we do that, if we go ahead and click 3 points and we want to make the same plane that we just did using the 2 edges, this edge and this edge here, we're going to highlight 2 points on one of the edges and then a 3rd point on the 2nd edge, which would be down here, and it creates the same plane as before. So you can see that, that plane there, if we get rid of it and then open up the one right before, you'll see that the 2-edge plane made the exact same one. Tangent to a face at a point. Choose the sphere's outer edge. This is where it gets kind of like wonky. Like I don't know when you'd ever use this, to be honest. Let's do it just for the practice, just for the hell of it. Okay, tangent to the sphere and this point. There we go. And that must be orthogonal. Yeah. Tangent to a sphere's face. Normal, orthogonal, same thing. So that means that there's a line. If you drew a line between this and the tangent plane to this, this would be 90 degrees. Again, I to be honest, I don't know when you'd ever use that, but good to know it's there. All right, click create, create sketch, then choose to create a sketch on the front plane or the XY plane. Okay. XY. Where are we? The front. Okay, here we are. Create a fit point spline, then draw a spline above the solid objects. Okay. Oh. Fit point. Oh, sorry, it's got 4 points. So remember how to add nodes to this? we right click on the spline and we come down here to insert spline fit point. All right, once we do that, then we have to actually go and click where we want that. So now we've got 3. That should have, interesting. So you can delete or add tangent, handles to an individual node. So that's pretty cool. Right now, this node doesn't have handles, which means you can't define the curve or the magnitude of that curve, but we can add that like that. Cool. That's great. That's kind of cool. All right, click construct plane along a path. Oh wait, then click finish sketch. Okay. Then click plane along a path. This is yet another way to construct. And what you'll see is that this plane, as we drag it, is going to, well, I already created it. Let's edit. I can click and drag it, and it's going to remain normal to the path at any point. So you can see it's kind of running through and changing its angle to remain normal or 90 degrees to the path that it's on. So then you can set or define where that thing sits on that path, which is super useful because the next thing we're going to do is we're going to create an extrusion off of this plane here. At least that's what I'm guessing they're going to have us do. I'm going to put it at the very end of the path. And then with that, we can use the, what is it, the sweep tool to create a profile that runs along that whole spline. Great way to create a really complex curve in a pretty straightforward way. Okay, yeah, they had us move it to the very end of the path. The next thing I'm gonna do is have us create a sketch on that plane. So I'm right clicking on the plane itself, create sketch, here we are. And interesting, so it shows an origin for the center of that plane, even though it's not the XYZ origin. At least that's what it looks like here. Okay, use the sketch tool to draw a circle coincident with the sketch's origin, then click the finish sketch button. And the origin is at the path center. You could also do it above, you could create your sketch so that the circle's above or below that. But in this case, they want us to have a circle at the center of the path that it's going to be sweeping along. All right, click create sweep. Let's rotate here so you can get an idea of what we just did. All right, quick review. We created a sketch, right? And we put a spline into that sketch. We finished that. Then we went up to construct, and we put a plane along this path, and by path I mean this spline, and that plane was right here at the end point. We then created a sketch on this plane, and that sketch is of a circle. So now we have 2 different sketches, and you need 2 different sketches in order to use the sweep extrusion tool. So we'll go to sweep, and here it's going to ask us to select 2 different sketches. The first is going to be the profile that is used to sweep along a path, which in this case is a circle. So we're going to click on that. The second is the path that it's going to take, which is going to be the spline. And there's a couple of other things you can do here. You can have it go a portion of the path, which would be distance. Taper and twist angle, I'm not so sure about. I've never used those. You could um, experiment with these various tools here, but that I think is all they have us doing in this tutorial. Okay, so that's it. One thing I do want to go back to is this spline here that they had us create. They never had us fully define it or turn the blue spline black, and that's something I think we should do, and we should make a habit of doing with all of our sketches. So before we finish up with this, we're going to go back using our timeline. All right, you can see here that if I click on this, it highlights the spline, and under sketches you get these dashed blue lines. If we go under sketch, we should see in dashed blue lines which one is being highlighted. Yep, see that I clicked on this and that lit up, so we know that it's sketch 7. And here's what's really cool. I can type in spline or path here on the sketch. So if you have like a million sketches, I don't know why that, anyway, let's go back. If you have like a bunch of sketches, you can identify them by naming them different things. So we have the spline, we've got the circle profile. So another nice way to identify your objects in your browser. You can also do this with the planes too. I mean, we can call this offset. We can call this edge. It's just one way to identify what you've already created. All right, enough said there. Let's go define this spline. All right, so as a review, we need to define all the points in space. Okay, so both their horizontal and their X component. And then we need to go and fully constrain the handles, each of their handles, which have a magnitude component and an angle component. So here it looks like we don't have a handle there. We've only got a handle here and here, so that's fairly straightforward. Oh, never mind. They were hidden. They were invisible. All right, we've got a bit of let's just say a bit of defining to do here. Yeah, let's make this easy. So 35. Let's make it the same using parametrics. Great. Let's define this with respect to itself. That'll be a new way of doing things. Let's go 10. 10. This is getting kind of messy really quick. So right now I'm simply, I want this to, there it is. Oh, right now it's defining the magnitude between those 2 points, and I want it to define just the vertical component. So in order to do that, I'm going to drag this down to make it more clear, or at least it should make it more clear. There it goes. So it snaps to that more easily. Okay, so what we've done just now is we've defined it with respect to itself. Okay, so that's helpful, but we need to define at least one of the points now to the origin so that we know where this thing is located in the plane. So I'll do that just with this point here. And I'm not even going to change it. I'm just going to leave it as is, but we need to dimension it so that it's so that it becomes fully constrained. Well, I might change this one a little bit. 25. Oh, geez. I guess I'll just leave it. Don't really mess it up here. Over constrain. Oh, because I've already. So the reason it gave me an over constraint there is I located this thing in space horizontally, or in the x-axis, if you will, and then I've already defined each of these other points with respect to one another in the x-axis. So I don't need to go back and define the dimension with respect to the origin, at least horizontally. Likewise, I have dimensioned each of these points except for this endpoint with respect to this node here. And then this node is dimensioned with respect to the origin. So all of our vertical dimensions are, aside from this guy, are constrained as well, which is good. So I need to go through and do this one as well. We'll make it the same. Great. So all four of our points now are fixed in space. They can't be moved, but our spline can still be manipulated with the handles. So we need to go through and define their angle and define their magnitude. So I'm doing what we did in the previous lesson, and I'm going to create a construction line just with respect to the horizontal for all my angles. Okay. You could do your construction line vertical as well and base your angles off of that, or at any other, some odd angle if you wanted to. But just to keep it simple, we're going to keep it the horizontal. 45. Let's go 45. Let's come back to that one. I'm just doing 45s because it's easy. It's doing some crazy stuff there. I'm defining its magnitude with that. I don't know what that is. Okay, so I'm defining the magnitude of this handle now. Keep it the same. This isn't the most pleasant curve, but we're getting it done. Okay, so this handle here has a magnitude on the left, has a magnitude and an angle. This one has a magnitude and an angle. This one has a magnitude and an angle. And this one has a magnitude and needs an angle. And then if we did everything right, we are fully constrained. Now this is just hideous. So what I might do, I'm not gonna mess so much with the spline itself, but I might make it look nicer, at least readable, by moving all these out so we can see what we're working with. It would have been helpful if I had just done one node, I think. Oh. Okay, that's just a little bit better. Okay, now we can kind of see what's going on. All right, now if I click finish sketch, we should see that profile kind of update to this new curve or this new path. So there, it did that. Give me a warning that it updated, but it should, well, it intersects itself simply because the curve is too short for this big of a profile, or it's got too sharp of a turn, but that's fine. Let's take a look at it from the side. Yeah, so right here is where it would intersect itself. Cool. All righty, that's that. On to lesson 6. Sorry, lesson 4-06.